Hello everyone, welcome to While One. So today's concept is recursion. We'll start off with an analogy which we've been all doing from our childhood and try to relate that analogy with our programming concepts so that we eventually understand recursion in a much better way. Let's start off with the analogy. So let's take a question of a multiplication. Imagine this question has been asked to a child, that is 5 times 7. So let's assume that the child is just a beginner in multiplication and he doesn't know the answer and he doesn't remember. So we as grown-ups, we know that it's there in our memory and we know that it's going to be 5 times 7 is 35. So but talking in terms of a just growing up kid and who's trying to learn multiplication, what he would do is he'll go back to a multiplication that he knows and is familiar of, and from there eventually he'll build up, that is he'll do repetitive addition. So we know that multiplication is just repetitive addition, right? So it's basically if 5 is kept added to itself, you're gonna get the tables, right? It's 10 plus 5, you're gonna get 15, so it goes on. So the child does the same exact thing. He's gonna go to a point where he knows the answer, and from there he's gonna do repetitive addition so that he builds up towards the question that he's been looking for. So 5 times 2 would be 5 plus 5, that's adding 5 to the previous answer. He's going to get 10, right? So 5 times 3 would be the same thing plus 5, and he's going to get 15. If I ask the same question again, it's going to be 5 times 4, that would be this thing, 15 plus 5, 20. So you get the idea, right? It's just basically repetitive addition, taking the previous answer and adding 5 to it. This exact same thing is known as recursion. So let's understand in terms of programming language so that we understand how recursion can be implemented in functions, and we'll understand this in a clear way. So now let's talk in terms of programming. So recursion is basically a function which is trying to call itself again and again. So this function call is going to go until a point where it's no more going to call itself. So this point will be known as the base condition, or so let me just help you picturizing it. So if this is a function, it's going to call itself again and again until a particular condition is met. This is this exact same thing that we had done in our childhood of asking, when given a question, what is 5 times 7? We had asked ourselves what is 5 times 6, what is 5 times 5, and eventually we came to a point, we know that 5 times 1 is 5, and from there we did our repetitive addition in our mind, and we took the previous answer, that is 10, we tried filling it, and then eventually we came to our question that has been asked, and we answered our question. So this is the exact same thing that we're going to do. So we're going to take a function, we're going to ask it what is 5 times 7, and we're going to ask, so now that we don't know what is 5 times 7, we're going to ask, do we know 5 times 6? Or again, we're going to ask the same question. If we don't know, we're going to ask what is 5 times 5. We're going to keep doing this until we come to a point which we know, that is 5 times 1. We know the answer, that is 5 times 1 is 5, right? So from here, we're going to stop recursion. This is the point which helps us stop our recursion, and from here is where we're going to build up our answer, that is we're going to start returning the values. So from till here we were just asking the same question with a smaller input, with a smaller input, and we came to a point which we knew the answer of, and then this is the point we're going to start returning our values, and we're going to come with an answer that is 35. So let me just help you again. That is, we came to we're going to ask the question that is 5, what is 5 times 1, and we take this answer and we're going to add 5 to it, that is 10, and we're going to return this 10 to the previous thing, and 5 times 10 times, or 10 plus 5 would be 15, and 15 plus 5 would be 10, sorry, my bad, 20, and it's you get the idea, right? So it's just repetitive addition, and we're gonna do this exact same thing in an IDE and try to program it and understand how this can be implemented in Java. So let's move to the IDE now. So we'll be using Eclipse for understanding recursion. First thing, let's try to create a basic recursion which will lead us to a problem, and then it'll be good for us to discuss about it, and then later we'll relate it to our analogy and understand our recursion and get good understanding of how to write a proper working recursive program. So let's first make a basic function call. So this is where our function call takes place. This is a trigger point, and let's make the definition of the function. So as we have discussed in our analogy, a recursion is basically a function trying to call itself again and again, right? And we know of the fact that we've also discussed that we have to call the recursive function on a smaller input, and also there should be a stop to the recursion, else it's gonna go endlessly and we'll come to an error. So let's see what that error is about. So let me just try to resolve this thing I've done. So let me just pass the value as 5, and let me just pass the value as I. So let's see what happens if the value is not reduced. That is, if I don't reduce the value as smaller input, and also if we don't have a base condition. Let's see what happens. So we're gonna run into an error known as the stack overflow error. This happens when, so this is the error about. This happens when we don't follow the rules. That is, if we don't reduce the input in our next function call, that is recursion call, and also if we don't stop our recursion. And this happens when the recursion keeps happening and goes in an endless loop, and there's something called a stack memory where all the function calls are placed, and whenever the function is executed and completed, it comes out of the function stack memory. So this happens when the calls are stacked up again and again without completing, and the memory in the stack overflows. That's when our stack overflow memory happens, error happens. So let's see how to write a proper recursive function, and let's understand what do I mean by reducing the input in the next function call, and also let's understand how the base condition helps in stopping the recursion, and also avoiding this error which we just turned into. So first thing is, as I told, okay, let's start off directly by programming our multiplication problem. So let me rename this function multiply and so I need 5 tables and I need 7, right? This is the same question that we had asked. So this is our so we're going to perform multiplication for 5 times 7, right? So as we've discussed in our thing, what we had done was we took 5 times 7 and we kept asking if we know do we know 5 times 7. If we don't know, we asked a smaller question, that is, what is 5 times 6? Do we know that? If we don't know, we kept asking the same question on a smaller input, that is, do we know 5.5 5 into 5? Then we kept asking, and then eventually we came to a point where we knew the answer. What is 5 times 1, and from there we started repetitive addition, right? We're going to do this exact same thing in our program as well. We are going to ask the same question to ourselves on a smaller input, that is, what is multiply, so our 5 is basically n, and what is n times minus 1, right? So here I'll definitely help you in picturizing it, but we know the point, right? So if it was 7, we're going to ask, the next question would be, what is 5 times 6? That is 7 minus 1, 6, right? So that's the idea, and this is how we are going to reduce our question to a sub problem, and we are going to approach closer towards the base condition. So let's understand what is the base condition. So this is where our function recursion takes place, and we need to stop this. So how do we stop this? So the next thing is our base condition. So we are going to keep this condition as if our times variable is equal to 1. We are no longer going to make a recursive call again. So as we have seen here, we kept asking the same question to a smaller subproblem. We went towards the question that we know of, and here we didn't make any further recursive calls. It's where from this was a point from where we built our return values, right? So going back to our IDE, this is where we are not going to make the recursion call, right? So let's start off with discussing about the base condition, right? So we know that 5 times 1 is always going to be 5, and 6 times 1 is always going to be 6. So any number that is multiplied by 1 would be the number itself. So now if n times 1, what would be the answer for it? So it's going to be n itself, right? So if I ask a question, what is n times 1, is going to come here and it's going to see n times 1. So times is equal to 1, right? So we've already met the base condition. So here there's no more recursion call that takes place, and we're going to return the number n itself back. That is, the answer is going to be 5 itself. But if it is not 1, as we have in our example it is 7, we have to do repetitive addition, right? And this is the condition after which there is no more recursion calls, and we're going to return the number itself. So here I'll show you, and once we are definitely going to picturize it after this program takes place. So let's just perform the recursion here so that we get a clear understanding. And let me just change the return type. Yeah, so here if I execute this, we are going to get a return value as 35, right? So by this we know that our recursive function is functioning properly, and we have also followed our rules. We've taken the value, and the next recursive call that takes place, we are going to go closer towards the base condition. That is, from 7 we go to 6, and I'll help you picturize it in a diagrammatic format. But by this we know that we always call the recursion on a smaller value, and also the moment we reach the base condition, we are just going to return the value. This is the point where no more recursion takes place, so that we avoid our Stack Overflow error. Okay, so let's move towards the diagrammatic format. So here we have a program. Let's try to picturize our program in a let's try to trace our program in a picturized manner. So the first thing is, the first call that we make in our program is to the function multiplication of 5 times 7. So here we have two possibilities. One is, if the condition is satisfied, we can either return n, that is this particular line, else we can return m of a smaller input plus 5. So here the same thing happens. Either for this particular function call, we can either return n, or we can return a function call of 5 times 5 of plus 5. The same thing happens again here. We keep doing this, and again the same thing happens. 5 times 3 plus 5. Five times 2 plus 5, and 5 times 1 plus 5. This keeps going, but in our condition, this particular branch is not going to enter, because at this particular recursive call, our condition for the returning of n is met. That is, our times value is equal to 1. So here this condition is met, and the branch is omitted, and we stop our recursion. And this is where our return happens. So this particular function gives a return value of n, so which is 5. It returns a value of 5. So this gets replaced by 5 plus 5, and this value is returned back as 5 plus 5. That would be 10, right? So this value is replaced as 10 plus 5. That gives us a value of 15. Now this value, since all these are return values, that's the reason I'm returning them back. It returns back, and the value of 15 is replaced with this. 15 plus 5 is given as the answer, and this 15 result in a 20. This goes back, and we get a value of 20 plus 5. That is 25. This value is replaced, it is returned back to this particular function, and we get a value of 25 plus 5. That is 30. This value is returned back, and we get finally our answer as 30 plus 5. That is 35. So that's the tracing for our program. I hope you've all understood how recursion works. So let's brief about recursion. First thing is, the function call should be made on a smaller value. That is, as we've shown here, if the value is times, it should be a times minus 1. This is just an example. It can be it can be call of any sort. So here we get this, and then there's another condition, that is the base condition needs to be taken care of. So a smaller input and base condition, this will lead to a stop in recursion, and the return values happens, and this is how the values are populated, and finally we get the answer. So thanks for watching, guys. Please subscribe to our channel, and hope to bring amazing videos. Thank you so much.